Hi guys, Ryan here from Elite Automotive Diagnostics. Today we have a Renault Master in the workshop. The customer's complaint, as you can see there, is the check engine light is on and the service light's on. Currently it's on economy mode, as you can see. So we scanned the car. It's got one fault code in the engine computer, which is pressure upstream of the turbine implausible signal. So basically on this particular vehicle there is a sensor upstream of the turbo, as it suggests. So what we want to do is have a look at the live data to see why does the computer think it's implausible. So let's have a quick look. So jump into live data, all signals. So on this particular tool, we can actually use a search function rather than go through all this information here. If we pull this tab down and then use a search function, we can search turbine, as in that was what it was relating to. And we've got two parameters here: pressure of the upstream, which is what we're after, and turbine sensor voltage, which is interesting. So we'll grab both of those and we'll click show. So as you can see at the moment it's reading 900 millibar, which is atmospheric pressure. That's probably about right for this particular atmosphere we are in currently here. And as you can see, the voltage value reads 1.66 volts. Now on this particular vehicle, as the pressure obviously increases in the turbo, you would expect this voltage value to increase coherently with this pressure value here. So what I will do is I'll show you what I mean. So we'll start the van up. Just jump in quickly. The van's running, as you can see there, check injection. So if we look at the scan tool, we're still reading atmospheric pressure, or pretty much close to it. The turbine pressure sensor voltage is still 1.66 volts. So what we're going to do is increase the engine RPM to see, do we have a change? So as you can see, revving the engine, there is a very, very, very small change to the voltage of the sensor, but the actual millibar reading does increase considerably. So we're currently at 1000. I will do it again and increase the engine RPM. As you can see, we got to about 1400 millibar there. However, the sensor voltage didn't actually change very much. So that concerns me a bit. Is that what we call a bias voltage? So a bias reading that we're actually seeing on the scan tool when it's processed data, rather than it actually being a fault with the vehicle. So what we need to do is find the sensor, grab the sensor out, and do some testing on the sensor itself. So I'll pause it here and I'll pull you back when we are actually on the sensor. Okay guys, so we found the sensor. It's actually buried on this engine. It's right down the back. So if I can show you, see if I can get you in the shot. So we're just down there. You can't even see the sensor, you can just about see the connector. We're back probed into the signal wire just there, and we're reading 1.67 volts as the scan tool originally displayed to us. So back into turbine, pressure of the turbine and the voltage show us. So 1.69 volts, which is pretty much what we're showing on the multimeter back probed. Okay, so that signal wire would be coherent. It is actually producing 1.67 volts. Now the problem with this is that I think this voltage is too high, ignition on. I believe this voltage should be around about 0.5 of a volt. I don't like it, it's too high. And what I also don't like is that this millibar is fluctuating, but the voltage is staying fairly coherent. It isn't changing. So what I want to do next is basically disconnect the sensor and do a bypass test on the sensor, produce a 0.5 volt signal from an AutoSim Pro in order to see if we can clear the code. Currently, this fault code is a permanent DTC. So if we read the codes again, and we try and clear the codes, codes have erased. Let's read the codes again. straight back. So ignition on, we have a permanent DTC for this circuit. So what I want to do is disconnect the sensor, which is back down there, and then we're going to probe the signal wire and produce a signal using the AutoSim Pro to see if we can then get the fault code to clear, which will then obviously confirm wire integrity and our theory that this reading key on is too high. So I'm going to pause you here, I'm going to grab out the sensor because it's absolutely buried, and then I will show you guys the bypass test and we'll go from there. Okay guys, so I got the sensor disconnected, as you can see here. Obviously that was back down there earlier. We're currently in the middle wire on this connector, which is the signal wire to the engine computer. We just scanned the car again, and now we have obviously two separate codes because of it's unplugged. So obviously lower limit. So on this particular vehicle, we are currently reading 0 volts. So it doesn't have a 5 volt bias on this wire. It is 0 volts, and the sensor itself produces the signal back to the engine computer. So as I said earlier, what I wanted to do was, because I thought the voltage was too high, the key on, ignition on only, was to produce a voltage that was less than 1.6 volts. So I am going to produce a voltage of about 0.7 of a volt. I think that's probably about right, between 0.5 to 0.7 of a volt, and see whether our code will clear. At the moment, obviously, both these DTCs are permanent codes. So I'll take you over to the tool. At the moment, as you can sort of see, we are producing a 0.7 volt signal. The sensor signal is off, so if we turn it on, it's now producing the signal. We'll confirm it with our multimeter, as you can see, 0.69 volts. We'll come out of here and see now if our fault codes will clear. So erase the codes. Yes. Yes. Codes have erased. Lovely. Let's now see if they come back like they were previously. Bingo. No fault codes. So, as I suggested, the voltage ignition on was too high. The engine computer was seeing this and was setting a plausibility fault code. However, interestingly, the millibar parameter was reading 1000 millibar. Let's see what it reads now. So back into all signals. Let's search the function. Turbine. Pressure. We are now reading 786 millibar, key on. So it's come down considerably. There. But yeah guys, just want to show you that one. A quick use of the signal generator to obviously bypass that sensor back there to confirm the wire integrity and that the sensor is faulty. That's all for me. Hope you guys enjoyed it. Thanks, bye.